Hello everyone, welcome back. My name is Bindu Kumar and today I want to discuss about mathematical operations which we can perform in R. So in order for us to achieve this, I'm opening my R Studio IDE. Once I open up my R Studio IDE, I should be in a position to open up my R script which I have safely saved in R scripts from my home folder. When I click on R scripts from my home folder, I just want to close this up. R folder. The second script is basic math with R. So basic math with R. Once I click it, I I'm in a position to open up my R script. So here, what are we going to discuss in this mathematical operations? First of all, we are going to discuss about summation and difference. Then further we will move on to how to perform multiplication and division. While we are performing division, I would like to discuss upon what is true division, how we can get the coefficients when one number is being divided by other number, something like a being divided by 3 or a being divided by b. Now, once I get the quotient, I have only one more thing which is remaining, and that is remainder. If at all my A and B are not perfectly aligned, I would be in a position to get some reminder. Once I discuss about division, I would safely move on to power, wherein like A raised to the power B. And finally, the inverse operation of power, which is nothing but logarithms. So here I am picking up A as 50 and B as 70. So here in my environment, I have A variable with 50 and B variable with 7. And once I perform summation of A plus B, I'm just using my keyboard shortcut Control Enter in order to perform this operation. On the line 12, I'm clicking on Control Enter, and hence I have computed my sum. In order for me to check what the sum is, I would just refer to the variable sum and again press Control Enter. So from here on, I would not mention about me using Control Enter so that the video doesn't become lengthy. But once we look at the sum, it is 57. Same with the difference, a minus b. So once I perform a minus b and look at the value in the variable, I have 43. As I have previously mentioned, if at all I am dividing 50 by 7, I should get some real number wherein I have something like 7.14832, whatever it could be. And if only I want to get the coefficient, here uh, 7 sevens are 49. So my quotient is 7, and once I get 49, my remainder is 1. I would like to show you how we will divide a number with another number. Once I use a slash b, it is doing a true division in the sense that I will get a real number as an output. Let me check what a divided by b gets me. So here you can see a divided by b is 1.742857. And if at all I want to get the coefficient, you can also see that uh, in order for me to get the coefficient, I can do yeah, how do I put it? I can just pick up the integer part of the real number and discard all my values which are coming after uh, dot. For me to quickly achieve quotient, I would just use percentile slash percentile b, and hence I get the quotient. So here you can see, as displayed in the previous example, my quotient should be 7. So here I am. I got a quotient of 7. In order for me to get the remainder, I would use a modulus operation. Modulus saying that a percentile b, and hence I get the modulus, and my modulus value is 1. Let me pick one more example. I would like to do something like 7 and 34. Okay, so to once I want to divide the number 34 by 7, what would be my result? So basically, when I am doing a true division, 34 divided by 7, it should result in some real number, and hence I can see my real number part, whatever it is coming up, 34 divided by 7 is 4.8571, so on and so forth. For me to achieve coefficient of 34 divided by 7, 7 fours are 28, so I should somewhere get 4 as my output. What I will do is 34 percentile slash percentile 7, and hence I should get a 4. Here you can see my result is 4. What if I want to get the remainder? For that, 34 percentile 7, and hopefully my result should be 6. And here we are, 34 percentile 7 is 6. I hope I have made my point clear in explaining how while dividing we get a true division, how we get a coefficient, and how we get a remainder. If at all we want to multiply two numbers, it is very straightforward, something similar to other programming languages, A star B. Once I multiply A and B, I get 50 multiplied by 7, which should be 350. Let me check the output, and yes, and hence we have got 350. Now I want to talk a little bit about power. So 2 raised to the power 4, what does this mean? It means 2 multiplied by 2 multiplied by 2 multiplied by 2, so on and so forth till 4 times. As my power is 4, I am multiplying it 4 times. Rather than writing out 2 star 2 star 2 star 2, I would just simply create a power and then get my result quickly. Here it is 2 raised to the power 4. So here I have got 2 raised to the power 4 is 16. We can even do the same for 50 raised to the power 7. What would that be? It should be some very huge number, and hence R kind of simplifies me the result by showing it in scientific format. Here E stands for 10. So here 7.8125 multiplied by 10 to the power of plus 11. That is how it is read. The inverse operation of power is logarithm. For me to get a natural logarithm of any number, I would just simply write logarithm of x, and that should give me natural logarithm. So natural logarithm of 10, what would that be? Let us check it out. It is 2.302585. What if I want to get logarithm of a number to the base 10? For that particular purpose, there is a function specifically designed to achieve this, and it is log 10. Hence, log 10 to the base 10 should give me 1. Let me check it out, and hence we have got 1 as our output. What would be logarithm of 10,000 raised to the base 10? It should be 10 logarithm of 10 to the power 4 to the base 10. So my base 10 and logarithm of 10 kinds of cancels out, and uh, I would be getting a result of the power, which is nothing but 10 raised to the power 4. Hence I should get 4. Let me check it out. So here you can see logarithm of 10 logarithm of 10,000 to the base 10 is 4. What if I have some arbitrary number and some arbitrary base? So here I have provided you with an example where we are trying to perform logarithm of 81 to the base 3. For these purposes, it should be logarithm of x comma base y. This should give you some clarity, but still, like logarithm of 81 to the base 3, 3 to raised to the power 4 is 81. Hence I am expecting an answer of 4 for this particular situation as well. Let me check it out, and voila, there you go. Logarithm of 81 to the base 3 is 4. What if I want to get logarithm of 1024 to the base 2? I can write it as logarithm of a given number to the base 2, and I get result as 10. I also have a specific functions which states log 2 to the number. Log 2 to the number kind of performs the same operation whatever we have performed earlier. It would be logarithm of the number to the base 2. Hence, my results should match. So here you can see logarithm of log 2 of 1024 is 10, and even though I explicitly mentioned logarithm of 1024 comma base 2, so here I am explicitly mentioning, whereas here I'm making use of a built-in function. What is logarithm of 1? Logarithm of 1 is obviously 0. Hence we get logarithm of any 1 to any base. It could be logarithm of 10 of 1. Even in this other cases also, any logarithm of 1 should result in 1. Sorry, logarithm of 1 should result in 0. Hence I get 0. I just want to touch base upon some edge cases. What should logarithm of 0 be? Basically, logarithm of 0 is undefined, or sometimes people say it, call it as infinity. But whatever be the case, uh, for us to understand how this works, I just want to execute the command and see the result. So here, it's when I execute logarithm of 0, it says minus infinity. This should give you a clue of how logarithm works inside the R environment. What happens if I give a negative number to the logarithm? Negative logarithms does not exist, but still, like here we can see logarithm of minus 32. It should result in some arbitrary garbage value, but let us check it out what happens. So here NaN, not a number, is introduced while we are performing logarithm of a negative number, and here in the warning message it clearly states logarithm of minus 32 produced, not a number, NaNs produced. What if I want to uh, you know calculate logarithm of a very small number? Here I have almost used 10 raised to the power of minus 10. Let me check it out with uh, normal logarithm. Once I perform normal logarithm, I get something like minus 23.022585. But this is not what I am expecting. I should get something like minus 10 or whatever it could be, since I have something like 10 zeros or 9 zeros appended before 1. In order for us to achieve a proper logarithm of the stated infinitesimally small number, log 1p is used. Hence, once I use log 1p, you can see now I get the answer whatever I am expecting, 1 e to the power of minus 10. So this concludes a brief introduction about how uh, various mathematical operations are performed in R. Basically, we have touched upon summation, we have touched upon difference, we have touched upon multiplication, we have touched upon division, wherein within the division we have looked at what is true, what does true division mean, and how to get the quotient and reminders between two numbers. Further, we moved on to explain how we can raise any number to the power of another number. Finally, we have looked upon logarithms, which are a natural amalgamation of inverse operations to power. Finally, this lecture concludes here, and if you like my video and you want to suggest me some problems where you are stuck, I'm happy to help you. Please uh, do like, subscribe, and comment so that this particular series will be available to some members where it could be very much helpful. Thank you all.